Here we're asked to solve an absolute value inequality. If you look at the printable notes, this is actually case 3 of the theorem. So the argument here is x plus 3. Either the argument x plus 3 is less than negative 5, less than or equal to, or the argument x plus 3 is greater than or equal to 5. Okay, so for example, like negative 6. If this was negative 6 in absolute value, that would be 6, which is greater than 5. Same thing here. If this was 6, the absolute value of 6 is greater than 5. So once we have that, we have two inequalities we could solve like normal. Here, subtracting 3. All the numbers less than or equal to negative 8 will solve the original, or when we subtract 3 there, x is greater than or equal to 2. So here's two intervals. Let's go ahead and graph those on a number line. Here's my number line. Now let's use closed dots because that equal there, that's inclusive. And shade in all the numbers less than negative 8. Infinitely many solutions there. And then let's use a closed dot at 2. And shade in all the numbers greater than 2. So here's all the numbers that'll solve the original inequality. You can actually take some of these and plug them in and see if they work. But I'm going to convert this into interval notation. So for this interval, I have negative infinity up to negative 8, inclusive, so I'm going to use a square bracket, union, inclusive, square bracket, 2 to infinity. This is the interval notation for the shaded region, all the numbers that solve the original absolute value inequality.